Okay, ladies and gentlemen, welcome to page 2 for Unit 5. We are going to be starting with number 6. Write the following asymptotes, both horizontal and vertical, for the following functions. So, for the horizontal parts, I have to look at whether the equation is going to be top heavy, bottom heavy, or equal heavy. So, looking at the x squared right here, this is considered to be top heavy because it has a higher exponential value for the variable x. Since this is top heavy, there's actually no horizontal asymptote, which actually ends up creating a oblique asymptote, but we don't need to worry about this for this example and for the test. But the vertical asymptote, what we do is we set the bottom equal to 0, and we should get x is equal to 4. Once we get x equals 4, we're pretty much done with that problem. No horizontal asymptote, x is equal to 4. Moving on to the second, we can see the x squared is going to make it bottom heavy, so the horizontal asymptote is going to be y equals 0. Now it's really important to include that it is y equals 0 rather than just 0. Now the vertical asymptote, we're going to say x is going to be equal to 3, but make sure that you also remember that there's a plus or minus if you end up factoring that. So it's x minus 3, x plus 3. The next one, this is going to be an equal heavy example. So what I do is I take a look at the coefficients that are of the highest power. So if I take a look, 1 is actually going to be a part of the x squared, and the 4 is part of the x squared for the bottom. So my horizontal asymptote is going to be y is equal to 1/4. And you want to look for the highest powers coefficients, and they will end up giving you some type of fraction. The vertical asymptote, on the other hand, 4x squared minus 16 is going to be equal to 0. I see that both are divisible by 4, so I could say x squared minus 4 is going to be equal to 0, x minus 2, and x plus 2 are going to be our values for the vertical asymptote. So x is going to be equal to plus or minus 2. Now let's take a look at the examples for number 9, 10, and 11. So this says write in exponential form. So the thing that you need to remember here is base to the answer is equal to the inside. So base, which is 5, to the answer, which is 4, is equal to the inside, which is x. Base to the answer, okay, make sure that that is also in parentheses, is equal to the inside. Base, even though there is no base here, since this is natural log, e is going to be the base to the t is going to be equal to 10. Now moving on to 12, 13, 14. When we organize the log, we start off with the base here, but base to the answer is equal to the inside. So the answer here is actually going to be t, while the inside is going to be 16. So log base e, but when we're writing log base e, we don't need to write it that way. We write it as ln of 18 is going to be equal to 3x. Now, if you're still not sure whether this might be stated correctly, you can always do it backwards. So base to the answer, so e to the 3x is equal to 18. Then we're good. So last one, log base 4 of 16 is going to be equal to x minus 4. All right, moving on, let's solve these problems. So what I do is I reorganize it into exponential form and see if I can figure out the answer from there. So since this is a non-calculator section, most likely I'm going to have to use mental math to figure these things out. So base to the answer is equal to the inside. 4 to the 3 is equal to x. So 4 times 4, which is 16 times 4 again, which is going to give me 64, is equal to x. We're good to go. 3 to the x is equal to 27. X is going to be equal to 3. 3 times 3, which is going to be 9, times 3 again, which is going to give you 27. X is going to be equal to 3. And the last one. X to the third power is equal to 1 over 27. Now, to get x by itself, what we can do is we can do something called the cube root. So if we do the cube root to both sides, so cube root of 1 is still just 1. Cube root of 27, which is 3, and therefore we get the answer x is going to be equal to 1/3. Now moving on to these last problems, what I'm going to work with is I'm going to solve it in the exact form. But if you do not want to use the exact form, you can always round to 3 decimal places or taking the value that I get at the very end and converting into a decimal. So I'm going to give you guys the exact answer. I'm going to work them out without actually using a calculator and then go from there. So the first thing I do, I see this minus 7. I'm going to add 7 to both sides, so I get 3. E to the 2x is equal to 57. Divide both sides by 3. 3's cancel out. I'm left with e to the 2x is equal to 19. After this point, I want to try and get rid of the e, and I want to bring down the 2x. So to do that, what I do is I do ln, I make both sides ln. So the e's and the ln cancel out, so it breaks down to 2x, and then the right hand side is ln of 19. After that, divide both sides by 2, and so my value for x is going to be equal to ln of 19, and then all over 2. And yet again, you can keep your example just like that. At this point, ln is by itself, but there's no ln on the right hand side. So what I'm going to do is I'm going to change this to exponential form. So we're going to say e to the second is equal to x plus 4. And that will make the ln go away. What it basically does is make the value on the right hand side the exponent of a base of e. And that will also get rid of the ln as well. So I can change this to a decimal, or I could keep it just like this form, just similar to how we use pi. Subtract 4 to both sides, and I get e squared minus 4 is equal to x, and there's my answer. Next one, 3x minus 1 is equal to 7 to the second power. Base to the answer is equal to the inside, so I end up getting 49 is equal to 3x minus 1. Add 1 to both sides, so I get 3x is equal to 50. Divide both sides by 3, and I get 50 over 3 is going to be equal to our value for x. Next, 21. Since I have 2 logs, we need to make sure that we put them together before I get rid of it. So to put these 2 logs together, you need to combine them. Since they're addition, we're going to multiply the x and the x minus 5. So I'm going to say x times x minus 5. And then make sure that that's all 4 log base 6 is equal to 2. Now, once you get the log by itself on one side, you can now switch it over to 6 to the second power is equal to whatever's on the inside. So I end up getting x squared minus 5x, I'm just distributing ahead of time, 6 to the second power, which is going to give me 36. Bring the 36 over to the opposite side, x squared minus 56, minus 5x minus 36 is going to be equal to 0. 2 numbers that when you multiply, you get negative 36, but when you add, you get negative 5. That's going to be negative 9 and positive 4. Now, x is going to be equal to positive 9 and negative 4, but you still have to make sure that you check for extraneous solutions. So if I take the 9 and I plug it in, I get a positive value inside the log. The idea is that I don't want a negative value. So this negative 4, if I place it into the first log or even the second one, it's going to get me a negative log, which is actually extraneous solution. So you still need to check those as well. Why we don't need to check for the other ones? Because for this example, if you take a look at e squared, that ends up giving us 2.7 something of that sort. And if you square it minus 4, right, just as long as it's greater than negative 4, we are good for 19. All right, and 22, what I'm going to do is I'm going to write this 3 over 1 and then cross multiply both sides. So I end up getting 50 is equal to 3 times 1 plus e to the 2t. Now there's multiple ways of doing this, but what I'm going to do is I'm going to multiply the 3 into this quantity on the right hand side. So I'm going to say 50 is equal to 3 plus 3e to the 2t. Subtract 3 to both sides, so I end up getting 47 is equal to 3e to the 2t. Divide both sides by 3. Since those don't go in evenly, I'm just going to keep it just like that. 47 over 3 is equal to e to the 2t. Now to get rid of the e, I'm going to make both sides ln. Those in a sense cancel out. So I'm going to say ln of 47 over 3 is equal to 2t. Then divide both sides by 2. And in a sense, this is going to be our answer. So we're going to get t is equal to ln of 47 over 3 divided by 2. And that's my answer. Okay, hope you enjoyed the second page of Unit 5 review. If you have any questions, please make sure that you comment below. Click the link in the top right-hand corner to go on to the next page. Click the link in the top left-hand corner to go to the previous page. And thank you for watching.